Since the discussion about technology openness with regard to electromobility and the combustion engine ban is currently being held frequently in Germany, and some politicians are drawing pictures of a flourishing German combustion engine car industry of the future thanks to e-fuels. We want to take a look at and compare the two concepts of combustion engine with e-fuels and battery electric vehicle in this video. First, let's take a look at how the two climate-neutral mobility concepts work in principle. Both concepts have in common that renewable generation, mainly from wind power and photovoltaics, should be used as primary energy to accelerate a passenger car at the end, to convert the energy into kinetic energy. The steps in between differ significantly. In the case of e-fuels, the electrical energy is used to generate hydrogen with the help of electrolysis. In a complex process, the hydrogen produced is then used to make synthetic fuel, which can be used in a similar way to diesel or gasoline. In addition to the hydrogen, however, CO2 is also required. In order for the e-fuel combustion engine to be truly CO2 neutral, this CO2 must be filtered out of the air in a process known as direct air capture, which is also very energy intensive and therefore requires additional electrical energy. The whole thing is to be done in countries with better conditions for wind power and PV, such as Chile. Therefore, in the next step, the synthetic fuel must be transported to Germany by tanker and distributed here like gasoline via tanker trucks and service stations. For climate neutrality, of course, all these steps would also have to be carried out without fossil fuels. In the final step, the e-fuels are then converted into kinetic energy in the combustion engine. In the case of the electric vehicle, on the other hand, the renewable electricity is generated directly in Germany or Europe and transported via lines to the charging station. There, the alternating current is converted into direct current, and then the battery in the vehicle is charged. When the energy is needed, it is converted back into alternating current via power electronics and converted into kinetic energy in the electric motor. When the speed is reduced, some of the energy can be recovered and stored in the battery. Let's take a look at the efficiencies of the individual process steps. The values given here are average values, and what is important is the orders of magnitude. The one or other percentage point more is still possible from a technical point of view for both technologies, but the order of magnitude will not change due to physical laws. Let's first take a closer look at the carbon-neutral internal combustion engine. Electrolysis has about 70% efficiency. The synthesis of e-fuels, including CO2 extraction from the air, is 63%.
Transport is highly dependent on location and is neglected here for the time being in favor of e-fuels. The internal combustion engine averages about 30%. To prevent the comments, yes, a modern diesel reaches 40 to 45% at the best point, but at this one drives in real life just rarely. With electric cars, the transport efficiency is about 95% due to line and transformer losses. The conversion to direct current during charging is also 95%, and for storage also about 95%. The conversion in the power electronics is also estimated at 95%, and the motor only at 90%. These are here also all average values, and by the fast development thereby rather estimations downward, an e-motor in modern electric cars reaches, for example, also already 97%. Also, the possibility of the electric car to recuperate is not yet considered here, and nevertheless one comes with e-fuels on about 13% and with e-cars on about 73% efficiency in the total chain. So, with free transport, RE plants abroad would have to be about 5 times as efficient. While typical wind turbines in Germany have between 4,500 and 1,800 full load hours, depending on location in Chile, up to 6,500 full load hours are possible at the best locations. A factor of 5 is therefore only achieved if one compares the worst locations in Germany with the best locations worldwide. However, if one wants to rely on e-fuels worldwide, there are also not an unlimited number of these locations. Whether it makes sense from the point of view of CO2 reduction to produce e-fuels for Germany at the best locations in Chile, or first of all to decarbonize the energy system in Chile, is a completely different topic again, keyword modern colonization, but that is beyond the scope here.
Anyone who now says, but the e-car produces much more CO2 in production. Let's take a closer look. A study by Transport and Environment examines the total life cycle CO2 emissions of an e-car and a comparable combustion engine that uses e-fuels. Even if 100% of the energy in both cases comes from renewable generation, the electric car produces 27% fewer CO2 emissions over the entire cycle. Predicting from the respective real-world electricity mix in 2030, the difference is as high as 53%, and the difference becomes even greater when using a mix of fossil fuels and e-fuels. From this point of view, the combustion engine with e-fuels is clearly inferior to the electric car. So, the advantages of electric cars are that they are much more efficient. It is also locally emission-free. Transportation is much easier, tends to have fewer losses as a result, and generates fewer additional emissions. In addition, electric cars can recuperate. There is no dependence on e-fuels from other countries. On the other hand, there are higher yields for PV and wind power abroad, and for example, there is much more space in desert regions than in Germany. Those who are now looking for the raw material argument for materials such as lithium and cobalt as an advantage of e-fuels, here, in my view, new battery concepts, e.g. sodium-ion batteries, are more likely to have an advantage, since combustion engines are also dependent on raw materials. From a German point of view, a dependence on raw materials can only really be tackled with both concepts through a circular economy. In sum, it's not surprising that even German automakers, with the exception of Porsche, don't really seem to be backing e-fuel. For example, Audi CEO Markus Duesmann says,
"We are phasing out the internal combustion engine in 2033 because the battery electric vehicle is the most efficient method for individual mobility.
And
Aircraft will rely on e-fuels or the passenger cars that are already on the road."
VW and Mercedes also supported the ban on internal combustion vehicles and had already planned for the ban, with VW commenting that
this is the only ecologically, technologically, and economically sensible way to replace internal combustion engines as quickly as possible.
For example, VW recently increased its target for e-car sales share to 80% in 2030. According to the latest discussion, however, they are currently keeping a back door open again due to political uncertainty. Of course, this is anything but planning security and could, in the worst case, set the automotive industry, which is not in a good position in terms of e-mobility anyway, back even further. Since e-fuels are still a relatively new technology, it will take time until production capacities are available. These should then be used first in any case where others are not possible, such as in aviation or shipping. Should the fuels then be so cheap, there will still be more than enough existing vehicles in the passenger car sector worldwide that could be operated with e-fuels in 2035. But even studies by mineral oil companies, which see synthetic fuels as a potential new business field, do not see such quantities. They expect that in Europe only 0.4% of the fuel demand in road transport can be covered by e-fuels in 2030 and 3% in 2035. Clear framework conditions should also be created in the interests of the automotive industry. From a technical point of view, internal combustion engines with e-fuels are simply far inferior to electric cars in the passenger car sector. Even though German companies are market leaders in many areas of combustion technology, holding on could lead to a story like that of Kodak or Nokia, which also missed a technological leap as market leaders and were left behind. That would be damaging for the entire German economy. Take a look at how the vehicles differ, even with the different drive concepts, and leave a like if you enjoyed the video.